This Bertaux's hint will cover several aspects of the concept of elasticity. A helpful visualization for this concept is a simple rubber band. When you hold a rubber band and exert force on it and stretch it, you are experiencing the elasticity of the rubber band. If the rubber band expands only slightly, it is less elastic than if it expands very significantly. So let's call this inelastic, and we'll call this one elastic. Now, with that visualization in mind, we're going to be talking about four kinds of elasticity. These are price elasticity of demand, price elasticity of supply, income elasticity of demand, and cross-price elasticity of demand. If you hear a reference to simple elasticity in economics, then we are typically talking about price elasticity of demand. In each of these types of elasticity, we can think of a general formula where E, which is going to represent a coefficient of elasticity, is going to be equal to the percent change in a variable that is, we can think of as an effect variable, divided by the percent change in what we're going to think of as the cause variable. And we'll give you an example of this. So here is our example from price elasticity of demand. When the price of gas drops by 50%, consumers buy 25% more. What is the price elasticity of demand? First, we identify the cause variable and the effect variable. Well, the cause here is clearly going to be the price of gasoline. When it changes, something happens. The effect variable is going to be the quantity demanded of gasoline, because when that price changes, consumers buy more, which means their quantity demanded has changed. The formula for this elasticity is going to be the percent change in the effect variable, which is quantity demanded, divided by the percent change in the cause variable, which is price. Since we know these percent changes, we just fill them in. The percent change in quantity demanded is 25, and the percent change in price was 50, and we therefore get the figure of 1/2 or 0.5. Notice that it is our convention here to ignore a minus sign. Namely, the price of gas is dropping, so this percent change in price, this 50, really is a negative 50%, whereas the consumers are buying 25% more, which means this 25 is positive, so a positive over a negative should give you a negative coefficient for your elasticity. The price elasticity of demand is actually always negative because of the law of demand. When price goes up, quantity goes down, and vice versa. But it is our convention to ignore it, so you could think of the absolute value of elasticity, meaning we ignore the minus sign. Now, note that our elasticity coefficient was a positive number. It was between 0 and 1. In general, when the absolute value of an elasticity coefficient is less than 1, we call this inelastic. And when that value is greater than 1, we call it elastic. Remember the not-so-stretchy rubber band for inelastic and this very stretchy rubber band for elastic. Now looking at the other types of elasticity, starting with price elasticity of supply. Okay. We'll call that ES. And we want the percent change in the effect variable on top. That's now going to be quantity supplied instead of quantity demanded, as it was in number 1. And on the bottom we'll have the cause variable, which again is going to be the price of that good. When we look at the income elasticity of demand, we'll call that EI. That's going to be, what's the effect now? Well, now the effect is going to go back to being quantity demanded, but the cause is not going to be a price change. It's going to be a change in income, the percent change in the income of demanders. And finally, in the cross-price elasticity of demand, we're going to call that EX, Y. We're going to take the percent change in the quantity demanded of one good, say good X, and that's going to be the effect. But the cause is going to be a percent change not in the price of X as it would be for the price elasticity of demand, but the price of another related good. So that's good Y. So those are all following the format of the percent change in effect on top, the percent change in cause on the bottom. Okay, the last thing we're going to talk about in this hint is how we calculate percent change for elasticity purposes. You are probably used to calculating percent change in this manner. If we have a value x1, let's say it's 10, and we have a value x2, let's say that's 14, you're used to calculating the delta x as x2 minus x1, okay, or 14 minus 10 equals 4. This will all work perfectly well for elasticity purposes. It's the next part that you have to pay attention to. You are probably used to taking your delta x and putting it over the initial value of x1 to get your percent change. So that would be 4 over 10, or 40%. We are not going to calculate percent change in that manner. We are going to use what's known as the ARC method, and we're going to take that delta x and we're going to divide it not by x1 but by the average x. Okay? So that's going to be delta x over x1 plus x2, sum divided by 2. Okay? So in our example, our delta x is still 4, but our average x is going to be 10 plus 14 divided by 2, which is 24 divided by 2, which is 12. This is a very different percent change. We now have 1/3, or 33%. This is how we will calculate percent change when we're doing elasticity calculations. This is our final example for this hint, and we're going to be using our percent change formula that we just developed. So here's the problem. The price of gas falls from $4 to $2 a gallon. The quantity demanded increases as a result from 1 million to 1.2 million gallons. So we want to calculate elasticity coefficient and identify whether it's elastic or inelastic. So we want to say, what is the percent change in the effect variable, quantity demanded, over the percent change in the cause variable, which is price. So this will be the change in quantity demanded divided by the average quantity demanded. And on the bottom, we'll have the change in price divided by the average price. It's always useful to look at your problem and label. So in the case of price, we have P1 equals 4. It starts at $4. And P2 is $2. And for our quantity is initially at 1 million, and it ends up QD2 at 1.2 million, just to keep your P1s and 2s and your QD1s and 2s straight. So the more detailed formula for your elasticity is going to be rather messy. You're going to put the change in QD, which is QD2 minus QD1, all over the average QD, which is QD1 plus QD2, divided by 2, and then that expression is going to go over the same thing for price. So on the bottom of this, you'll have P2 minus P1 for your delta P, and that's going to be over your average P, which is going to be P1 plus P2, divided by 2, and that is going to be also a separate expression. So in the next step, we're going to plug our values here for P1s and 2s and QD1s and 2s into this expression to get our final number. So now we plug and chug, right? We have our elasticity coefficient. We have QD2 minus QD1 up here. We're going to plug that in, and that's going to be 1.2 minus 1. We're going to put that over the average of those two, 1.2 plus 1, or it could be 1 plus 1.2, doesn't matter what order you add those, divided by 2. Okay? And then that's all going to go over P2 minus P1, which is 2 minus 4. And that's going to go the average P, which is 2 plus 4. Again, it doesn't matter what order we add those two numbers, but we're going to divide the sum by 2. And that's going to be an expression. Okay? So breaking that down, it's going to be 0.2 divided by 2.2 divided by 2, which is 1.1. So that amount will be over 2 minus 4, which is actually a negative 2. And remember, we're going to ignore the minus sign here, so we can just call that 2. And over the average of those two, 2 plus 4 over 2, that's 6 over 2 is 3. Okay? So that's an expression. So we have to use our calculator for that. The top is going to be 0.182 to 3 digits. The bottom is going to be 0.667 to 3 digits. And that computes to 0.27, and that's to 2 digits. So our final question is this elastic or inelastic? Well, because its absolute value is less than 1, it's going to be inelastic.